So we're back continuing work on 12.1, number 21, and we left off right here trying to find the critical value. So the critical value will be equal to chi, oopsie, had to click on it, chi, C-H-I-S-Q dot I-N-V, because it's inverting, dot R-T, because this is right-tailed. All goodness of fit tests are right-tailed. Probability is 0.05, comma, degrees of freedom. All right, I'll put it right here somewhere. Okay, degrees of freedom. Let's put it right here. N would be equal to, actually it's K, is equal to the count of the number of categories you have, which of course in this case would be 7. There you go. Okay, so 7's not our degrees of freedom though. I left it that way. It's that much minus 1, which would be technically 6. All right, so there's our critical value. Life is grand. So, oh, how would you do it if you had old Excel? It'd be equal to chi inverse 0.05, comma, 7, take away 1. There you go, same number. Okay, so step 5, I'm going to put right here. Step 5. We would not reject the null hypothesis, because the test statistic, the chi 0 squared, which is 13.227, is not greater than the critical value of 12.592. In other words, it's not in the critical region in the tail, right? If you look right here. So you found this critical value to be 12.2. Oh, I'm a moron. Yes, you would. See, always pays to look it over. Reject the null hypothesis because the critical value is greater. There you go. The test statistic is greater than the critical value. See? Always, that's why I love to look at pictures of it. So let me think about this again. So our critical value is 12.9 something, right? 12.59. And then our test statistic is 13.2. So we're just barely past it. So we would reject the null hypothesis. Cool. All right, so let's do the p-value method. The p-value method is going to be equal to chi sq.dist.rt, that test statistic, comma, 7, take away 1. Old school Excel would be chi dist, 13.27, comma, 7, take away 1. There you go. Now notice that's a little bit lower than our alpha. Our alpha was 0.05. So we are going to reject H naught because P, which is equal to 0.0396, is less than alpha, which is 0.05. All right, what about lovely, lovely StatCrunch? Okay, so you would take these, and I like to keep the days of the week with it just to kind of keep my head in the game, as it were. All right, let me go find StatCrunch. There it is. And I'm on the same sheet I've been using before, but that's all right. So I'll just go over here. And I copied and pasted those in. Go to Stat, Goodness of Fit, chi-square. I observed, I've got them called observed frequency this time. You could number them. You could say like observed for 12.1 or observed number 21, expected number 21, like associated to the problem number or something like that. And there you go. Copy. And bring it over here. And paste. And I love seeing it back up what I had said, that the p-value was 0.0396. All right, let's go back to the problem. Is there a significant difference? Well, yeah, right? We just showed, right, step 6. Let me type this up because I'm running out of time. There you go. Oops, and I noticed that my alternative hypothesis hadn't changed, so I wrote up that at least one of the proportion of pedestrian fatalities is significantly different. And I found that there was evidence of that, right, that they are different. And in particular, you can tell it's Saturday. Saturday is the different day. Right there. All right, I'll see you back here later for 12.2.